All right, here we go again, 1.5, day 3, parent functions and transformations. You can go ahead and start by drawing each one of these parent functions, and this time stating their domain. Then we have one warm-up just to make sure we're okay with this, and then we'll move on to piecewise functions. So go ahead, pause your video, and try the warm-up. Okay, so here is what your first 3 functions look like, and then their domains and ranges. Go ahead and check those. Make sure you're okay with them. And here's the last 3. Okay, so let's get started with this warm-up here. I'll walk you through it just in case you struggled with it. So first off, let's talk about the parent. This is an x cubed, so the parent function is the cubic function. Notice this is supposed to say C, you're supposed to graph the parent with a dashed curve. So I'm going to go ahead and do that now. Okay. All right, now let's see what's happening here. I'm going to move left to right and just say what each thing is doing. So there's a 1/2 in front of the parent. So since it's in front, that's vertical, right? And it's outside the parent. Then I want to know what a 1/2 does. Usually a number bigger is what I've seen more than anything. It would be a stretch, but this is a compression. All right, next I see a negative in front of x, but it's inside the parent. So that's horizontal. And then a negative in front would make it reflect. So horizontal reflection. And then last but not least, there's this +1 on the end. That is a vertical translation. And it's moved up 1. Okay, so let's graph this now. So remember that critical point that's at 0, 0, I'm going to move that up 1. There we go. Okay, so now I have to vertically compress it and horizontally reflect it. So if I think about just horizontally reflecting this piece, it's going to be this way now, right? And then vice versa this way. But I also have to vertically compress it. So think about taking this and compressing it vertically. It's going to get much wider. So let's exaggerate that wideness, okay? Remember, you also have to horizontally reflect it and then vertically widen it. That I can tell it's widened. I don't have to say wider right next to it so that I know that someone, when someone's grading it. Okay, let's talk about piecewise functions today. So you've graphed piecewise functions before in Algebra 2. I'm just going to teach it to you a little bit differently. So when you graph piecewise function in Algebra 2, it was always just lines. As you can see in pre-calc, we do things other than lines. Okay, so I'm going to teach to you probably differently from what your teacher last year taught it to you. So if you want to do it the same way that your teacher taught it to you last year, as long as it matches mine exactly, then it's fine. Okay, so first off, what I want you to realize, this is the line y equals x plus 1. Sloped line, slope of 1, y-intercept of 1. This is the line y equals 5, which is a horizontal line. And then this is the line y equals negative 2x plus 3. A negatively sloped line with a slope of negative 2 and a y-intercept of 3. We're graphing those 3 pieces, but the first one we're only graphing from negative 2 to 2. The second one from negative 2 to 3. And the third one for all values bigger than 3. So here is how I do this. Start with one piece. I'm going to graph the line y equals x plus 1. Okay, and here's what I do. I make a table of values. What values am I plugging in? These values. -6 through -2. Don't even look at this yet. Okay, don't even look at that yet. I'm looking here, -6 through -2. So I'm going to plug in -6, -5, -4, -3, and -2. So now what I'm going to do is I'm going to plug those values into this equation right here, okay, for x. So I'm going to plug in -6. Negative 6 plus 1 is negative 5. I'm going to plug in negative 5, negative 4. Negative 4, I get negative 3. Negative 3, I get negative 2. Negative 2, I get negative 1. So now I have 5 points that I can graph. Now I'm going to look to see how I'm graphing it. So negative 6, negative 5, look here, it's a closed point. Here, if you look at this one, negative 2, negative 1 is an open point. So I'm graphing from a closed point to an open point. It should never be a vertical line. That's just the way I'm looking at it right now. Okay? All right. Negative 6, negative 5. I have a closed point. And then I have negative 5, negative 4. Negative 4, negative 3. Negative 3, negative 2. And then negative 2, negative 1, open point. Connect those. There's my first piece. Okay, next piece. Once again, I'm going to make a table of values. That's not where y's go. X, y. And I'm going to look to see what x values I'm plugging in. I'm plugging in negative 2 through 3. So negative 2, negative 1, 0, 1, 2, and 3. Okay, so now I'm going to plug in negative 2. Go ahead and plug in negative 2 for x. And I get an automatic output of 5. So this is 5, 5, 5, 5, 5, and 5. Okay, now I'm going to look to see what kind of points these are. So all that I need to know is the first one and the last one, and then I can connect them, right? So first one, last one. First one's closed, last one's closed, and then I'm going to connect them. So negative 2, 5. Close point. And then negative 1, 5, 1, 0, 5, 1, 5, 2, 5, and 3, 5. There's the next piece. All right, now I'm ready for the last piece. X, Y's. All right, look right here to see what I'm plugging in. So it says x value is greater than 3. So make sure you always plug in these numbers. Okay, people always want to be like, oh, you can't plug in 3 because it's x value is greater than 3. But you still need an open point there. So I'm going to do 3 and then 4, 5, and let's see if that's enough. Okay, but this keeps going on. I'm going to put an arrow there to tell myself, it keeps going on. You just stopped to see if it's enough. All right, let's plug in 3 here. Negative 2 times 3 is negative 6, plus 3 is negative 3. Negative 2 times 4 is negative 8, plus 3 is negative 5. Negative 2 times 5 is negative 10, plus 3 is negative 7. So notice they are going down by 2, just like it said it would. Okay, so what am I graphing here? This is an open point at 3, and then realize it goes forever. That arrow right there when I just stopped because I felt like it tells me to go on forever. Okay. So 3, negative 3, open point. And notice it has to be open because if it wasn't open, it wouldn't pass the vertical line test. I'd have 2 closed points there. All right, 4, negative 5, 5, negative 7. And it keeps going on forever and ever and ever. But I'm just going to put an arrow going on the end and stop plugging in values. All right, so that's how you graph a piecewise function made up of lines. Now we're going to graph a piecewise function made up of things other than lines. So if you look here, this is a line. This is a square root function. This is a line. This is a quadratic. Still just pieces of functions. We're going to do it the exact same way. All right, so I'm going to start with my first piece right here. Table of values, x, y. I'm going to look to see what values I'm plugging in. This says x values less than or equal to 0. So I'm going to put down 0, and now I'm going to put down values less than or equal to 0. So negative 1, negative 2, negative 3. Hopefully that's enough. If I need more, I'll plug in more. All right, so I'm going to plug in 0. I'm going to plug in 0. Negative 2 times 0 plus 1 is 1. Plug in negative 1, I get 3. I get 5, and I get 7. Look here, this is a closed point at 0. So there's a closed point here, and then realize it goes forever and ever in the other direction because I just stopped because I felt like it, right? Okay, so let's go on to the next piece. You could graph that piece right now if you wanted, but I'm going to go on to the next piece. Here's piece number 2. That just froze, so give me a second while I open it back up. Every once in a while that happens. Happens a lot in geometry. Okay, go back to it. All right, number 2. XY. All right, here I'm plugging in 0 through 4. 0, 1, 2, 3, 4. Once again, don't say I'm not plugging in 0 because it's right there. It doesn't have or equal to. You still need an open point there. All right, plug in 0. The square root of 0 is 0. Plus 1 is 1. Plug in 1. Square root of 1 is 1. 1 plus 1 is 2. Plug in 2. The square root of 2 is a decimal, so I'm going to go ahead and skip it. Square root of 3 is decimal, so I'm going to go ahead and skip it. Square root of 4 is 2. 2 plus 1 is 3. Once again, I look here. That's an open point at 0, an open point at 4. Open point here, and I'm going to connect them. Okay, 0, 1, open point. 1, 2. 4, 3, open point. 4, 3, open point. And then I'm going to connect them. Notice this is not a straight line. It's not supposed to be. It's a curve. I don't know why I immediately went and graphed that, but I'm going to go back and graph the other one too. Okay, so I'm going to graph now because I skipped graphing it for some reason. 0, 1 is a closed point, so now I'm going to close it. And look, it's now a closed point. It was open, but it's closed now. Negative 1, 3, right here. Negative 2, 5, right here. Negative 3, 7, right here. And then remember, I just stopped plugging in numbers because I could go on forever and ever. Okay. Next piece, table of values, x, y. And looky here, you're only plugging in the x value of 4. And when I plug in the x value of 4, it's telling me I get an automatic output of 4. So that means that I have notice it says equals, right? It wouldn't be there if it was open. So I have a point at 4, 4. All right. Last one, table of values, x, y. Look to see what I'm plugging in. I'm plugging in 4, 5, 6, and 7. If you want to even see ahead of time, 4 is going to be an open point. 7 is going to be a closed one. I'm going to connect them with either a curve or a straight line, and I look, it's a curve. All right, let's plug in 4. 4 minus 5 is negative 1. Negative 1 squared is positive 1. 5 minus 5 is 0. 0 squared is 0. 6 minus 5 is 1. 1 squared is 1. 7 minus 5 is 2. 2 squared is 4. All right, let's graph these points. So 4, 1 is an open point, and it has to be an open point because I already have a closed point at 4. 5, 0. 6, 1. 7, 4. And notice that looks like a part of a parabola. And there's my piecewise function. Okay, so table of values is key here. And if you're like, I did it a different way, I just graphed it this way, and I got the same thing as you. If you got the same thing as me, that's great. No need to do it my way, but my way I feel like is very steppy. Like you follow the steps, you get there. Okay, last one is the piecewise function is already there, and you have to write the equation for it. So I'm going to color code these because right now they're not that friendly. So here we go. We'll start with this first piece, the red piece. Okay. Now, if you look at that, that's a horizontal line. Horizontal lines are in the form y equals, and then it's whatever y value goes through. So first off, I forgot to mention, this is my least favorite graph paper the entire year. It's the stupidest graph paper. It's labeled, like the zero is labeled, so it's very hard to see. But that is at 1. That's the tick mark of 1. So that's the line y equals 1. So now when I write my piecewise function here, I don't write y equals because it's already here for me, but if I had to write my own piecewise function, I'd write it there. And then I'm going to write 1. Notice I then write if, and now I'm going to state the domain of that piece. That goes from -1, -2, -3, -4, -5 to 0. So I'm going to write -5 to 0. And notice it's always written, it's not written in interval notation, which we're used to writing to. It's inequality notation. Now I look and see that both of my points are closed. So I'm going to put the or equal to lines underneath that. All right, the next piece I notice is a downward facing parabola. So I'll color this in purple here. It's a downward facing parabola. Remember, parabolas are in the form y equals a times x minus h squared plus k. So if I know the vertex, then I can write the equation of the parabola, right? So this is y equals, their a value is 1, because I can see that from the vertex this goes up 1, down 1, right 1. It is, however, reflected, so that's negative. And then I'm going to do x minus, if you look where the vertex is, that's at 0, 3. So x minus 0 squared, so I don't need the parentheses anymore. And then plus k, so plus 3. So that's y equals -x squared plus 3. And that's if you look at the domain of that piece, it's from 0 to 3. So I'm going to put in between 0 and 3. At 0, it's open. At 3, it's closed. All right, the very last piece is a line. Write an equation of a line. It's in the form y equals mx plus b. So first off, I need the slope. You can use any 2 points you want. So I can see it's up 3 over 1. So that's 3x. And now I need to know the y-intercept. Right now, it's not hitting the y-axis. So what I'm going to do is I'm going to continue the pattern of the slope of 3 until I hit the y-axis. So from this open point right here, I'm going to go down 3, left 1. Down 3, left 1. Down 3, left 1. And I finally hit the y-axis. I can see that I hit at -7. So this is the line y equals 3x minus 7. And if you look for that, that goes from 3 to infinity. So that's for if x is greater than 3. Okay, that's it for today. That's it for piecewise functions. Go ahead and stop the video and start on your 1.5 day 3.